Hello everyone, welcome back to my YouTube channel. Today we are going to solve day 17 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3047. Find the largest area of square inside two rectangles. So let's read the problem statement. There exist n rectangles in a 2D plane with edges parallel to the x-axis and y-axis. You are given two 2D integer arrays, bottom left and top right, where bottom left of I has two values, a and b, and same way top right has two values, c and d. It represents the bottom left and top right coordinates of the ith rectangle, respectively. And you need to find the maximum area of a square that can fit inside the intersecting region of at least two rectangles, and we have to return 0 if such a square doesn't exist. See example number 1. Here bottom left if you see 1 1 and top right if you see 3 3. So let's say this is square A. So for square A we have bottom left values of a and b, or you can say coordinates x and y is 1 comma 1 and top right are 3 comma 3, this red colored square box. Same way after that if you see this square box b, so here 2 2 is the starting bottom left and 4 4 is the top right, this blue color box. Now if you see this C square box, not a square box, because here it's not it's 3 to 6, so length is 3, so it's a rectangle, right? So here if you see this green color box, bottom left coordinates are 3 comma 1 3 comma 1, this one, and top right coordinates are 6 comma 6, this one. Now in these three different boxes, what is the max square side that you can easily fit? So here if you see this one length I can fit here, same way I can fit one length here as well. So can I fit a square of side 2? Is it possible between the intersecting regions? Here I can't fit between red and blue. Can I fit in red and green? No, because here max length is only 1 from 3 to 4. So only one side square of side length 1 I can easily fit. So here what is the area? Area is going to be 1 into 1 1, so 1 is going to be the output. You need to find the maximum area of a square that can fit inside the intersecting region of at least two rectangles. Here if you see the explanation, a square with side length 1 can fit inside either the intersecting region of rectangles 0 and 1 or the intersecting regions of a rectangle 1 and 2. Hence the maximum area is 1. It can be shown that a square with the greater side length cannot fit inside any intersecting region of two rectangles. Here if you see the constraints, n is equal to bottom left dot length and top right dot length. So both arrays are having same length, and n value is also very small, 2 to 10 is power 3. So I can do one thing. I can maybe first time I select this square A, and then I compare this square A with square B, and after that maybe I pick square A and compare it with square C. If both are intersecting, find the max area. Here if square A and B are intersecting, find the max area. Next time I pick square B and I compare with square C, and that's it. So I can run nested loops. If I run the nested loops, my problem this is going to take 10 to the power 6 operations, and this many operation will not give you time limit exceed error. So we can run nested loops. And here if you see bottom left I dot length, so only two values are there, x and y coordinates, and all these values are in from range from 1 to 10 to the power 7. And important point, bottom left of I comma 0, this value is always going to be less than this value. Same way this value is always going to be less than this value. Bottom left I of 1 is less than top right I1. Clear? Same way if you see this example number 2, so square A, let's say, then square B, let's say, then this is square C. So here red color 1 1 2 5 5, this one until here, so this is square A. Same way if you see this 1 3 to 5 7, 1 3 to 5 7, from here to here, this is nothing but your square B. Square C is from 1 comma 5 to 5 comma 9, so this is your square C. So here I can fit rectangle or square, I can fit square because we only need to fit the squares, right? Or here I can fit some square. So what is the max length that I can fit? So see here, uh, here uh, here we can fit, right? And here if you see length is going to be, or you can say width, 5 minus 3 2. So here if 2 na, here it is 3, if you see x coordinate 1 to 5, so here 4, 2 and 4, definitely I have to pick the minimum among these, so 2 is the minimum. So square of side 2 I can easily fit, and if I'm going to fit square of side 2, then area is going to be 4. So same way here also, here we have option to fit 4 length, but here we have only option to fit 2 length, so I will pick the minimum only. So again area is going to be 4. So a square with side length 2 can fit inside either the intersecting region of rectangles 0 and 1 or the intersecting region of rectangles 1 and 2. Hence the maximum area is 2 into 2 4. It can be shown that a square with the greater side length cannot fit inside any intersecting region of two rectangles. So now this problem is very easy for us, right? We can pick two squares. So here let's say if this is one square and if this is one square, let's say square A and square B. So here if you see, and I'm going to give the points of square A and B like this: square A, bottom left x, square A, bottom left y. So let's see, read the coordinates like this: square A, top, square A, let's write it like this: square A, top right x, square A, top right y. So just read it like this so that you guys get clear understanding. Same way, read these coordinates like this: square B, bottom left x, square B, bottom left y. Same way, read these coordinates as square B, top right x, square B, top right y. Now here, using nested loops, I will find out two squares A and B. And for these two squares, I will find out if there is any intersecting region. So if there is any intersecting region, then we have to calculate the max area of a square that we can easily fit. But if there is no intersecting region, then we need to skip. So here, if you see, this is your x-axis, this is your y-axis. Now, for two squares to be intersecting, so they may be intersecting like this. Let's say square A, square B, the box A, box B. right? These are boxes, we need to fit square. So here also let's say these are boxes. Same way, maybe these two boxes may intersect like this, A here and B here. They may intersect like this. They may intersect like this, A here and B here. They may intersect like this, A here and B here. Right? All these ways. What else? Is there any other way? If you notice. So here AB and AB here. AB I'm writing here. Okay. Now, is there any other way? Think of it. B here and A. So that is simply this. So see, these are some ways, right, in which we can place two boxes. Now we have to find out the intersecting region. So intersecting region, how I'm going to find out? Intersecting region. It is going to be very simple. First, let's say how I'm going to calculate the width. And then after that, I will tell you how we are going to calculate the height of these two boxes. The intersecting, overlapping, I can say I will find out overlap width and overlap height. So that's what I'm going to tell you how I'm going to do this. So for these two, for this shape or any of these shapes, if you notice, the overlap width is going to be, if you just see this diagram first. So overlap width is going to be this one. Same way here, if you see, overlap width is going to be this one. Same way here, if you see, overlap width is going to be this one. Same way here, if you see, overlap width is going to be this one. Right? Now here, can I write my overlap width as the minimum of A underscore top right x my comma B underscore top right x. So minimum of these two, math dot min of these two, A top right x. So A top right x, here if you see in this shape, A top right x, that simply means I'm talking about this point, and B's top right x. B's top right x this. So among these 2 points, I am picking the minimum. So minimum is this. Same way here, minimum of A top right x. So this is A top right x, and here B top right x is this. So among them, I am picking minimum. So minimum means this point. Here, A top right x is this, and B top right x is this. So that simply means this point. Clear? Here, this point. Same way here in this shape, A top right x is this, and B top right x is this. So that simply means I am picking this top right x coordinate, right? So I am picking this one. So in all these shapes, if you notice, I have picked this point here, 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 x-axis, in the x-axis. This is your x-axis, 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 right? Now, from this, if I say I subtract the max of math dot max of A underscore bottom left x, B underscore bottom left x. So now tell me in all these shapes, max of first A bottom left x, A bottom left x is this, and B bottom left x is this. So among this max, so max is this. So I can easily say this x coordinate I am picking now. So I can easily say this point here, right? And here from this I am subtracting this, so that simply means I'm going to get the length of this. Same way here, this is one point I selected. Now math dot max of A BLX, A bottom left x, and B bottom left x. So among them maximum is this. So I'm going to pick this. So I will get this because I am subtracting from this. So this formula is going to help me in calculating. Same way here, A bottom left x this, and B bottom left x. So here this. So this
from this I am subtracting this, so I will get this length. Same way here, a bottom left x is this, b bottom left x this, so I am picking this x coordinate, so here this one. So from this and this I am subtracting, I am getting the overlap width. So in all these cases I am getting the overlap width. Clear? Now if you see this diagram, in this case, there is no overlap width, right? So in this case your overlap width is not going to be greater than 0. In all these overlap width is going to be greater than 0, but here it's not. So that simply means if overlap width is greater than 0, that simply means both are intersecting, there is some overlap width. Now there may be case for boxes like this, a and b here, but these two also not going to be completely overlap, only one edge is mixing. So in this case what I have to check, I have to make sure that my overlap width it should be greater than 0, and my overlap height it should also be greater than 0. So now I'm going to calculate this overlap height. That is also going to be very simple. So height, if you notice in this diagram, this is what I need to find out. In this diagram, this is what I need to find out. In this diagram, this is what I need to find out. In this diagram, this is what I need to find out, right? Only these points. Here, these 2 points. Here, these 2 points. Here, these 2 points. So how I'm going to write the formula for this one? So I can write it like this. First, give me the math dot mean value of a top right y and b top right y. So what is the among them? Two boxes I have placed now. Two boxes I have placed. So among them, tell me I have to pick the minimum of y for the top positions. For the top positions, these are the top positions. For these top positions, I have to find the minimum y. So that is why this is how I'm writing the formula. I have top positions. For these top positions, I am finding the minimum so that I will get this region. Same way, from this, I need to subtract. Now, these two boxes are here, this and this. So this point I have find out. Now this point I am going to find out. So this point definitely it is going to come the bottom. So bottom of these two and max among these. So I will get this point. This is how I'm writing the formula. That's how. Okay. And math dot max of now bottom. So here I will say a bottom left y and b bottom left y. This is for height. So here I am talking about y and here we are talking about x. Now in this way you are going to calculate this. So now if you want to check this diagram, you can find out easily. A dot top right y uh, is this and b top right y is this. Among them you have to pick minimum, so that means you selected this point. Then from this you subtract what? A bottom left y, this and this. Among them you are picking max, that simply means this. So from this you subtract this, you are going to get this. That's how you are getting it. Same way here, a top right y and b top right y, so you are going to get this. Then from this you have to subtract what is max of a and b by position, so this. So you have to select this. Now you are going to get this. Same way here, a top right y means this and b top right y, top right y is this. So among them what is minimum is this, so you are going to pick this. Then here and here what is max is this, so you are going to pick this. Now you are going to get this. Same way here, this and this, what is minimum is this. Then bottom max is this, so you are going to pick this, so you are going to get this. That's it. So now you are going to get overlap width and overlap height. So now if both are greater than 0, that simply means two boxes are intersecting. Now if two boxes are intersecting, now we have to find out the side. So here let's suppose this side, the overlap areas comes out to be 3, let's say, and in this side overlap area comes out to be overlap height and overlap width. Overlap width comes out to be 3, overlap height comes out to be 2. So among them you have to pick the minimum, because you need to fit the square box. So you have to pick the minimum among them, and whatever the side you are going to get, just multiply it with again side only, so that you get the area. That's it. That's it. And now I'm going to write the code. Very, very simple. Let's move to the code part now. So here, what you need to do first, long max area, and here you are going to write 0, and here int n is nothing but, you can say, bottom left dot length, and then you have to run two nested loops. Int I is equal to 0, I is less than n, and here I plus plus, and here for different square boxes you need to pick. So here I'm going to write I plus 1, j is less than n, and here j plus plus. Now here inside this we have to find out the coordinates. So a square box, box a, not square, square we need to fit. So box a, let's say bottom left x, bottom left x. Same way you have to write int square a only, but this time bottom left y, bottom left y. Same way you have to write square a only, but top left, top right x. Square a only, top right y. So these coordinates you have to write. So bottom left x and bottom left y is going to come from this bottom, is going to come from this bottom left 2D array. So here bottom left I'm going to write, and then here I, and here I'm going to write 0. Same way bottom left y is also coming from this bottom left only, but here 1. And now this top right, so this is going to come from this top right array, and here I have to write I only, because this I'm talking about square box A as of now. Here it's 0. Same way this top right y is going to come from top right 2D array, but here I have to write 1. That's it. Same thing I have to write for my square b, which is using j loop. So here I'm going to write, just I'm going to change it to b here everywhere, b. Here I'm going to change it to b. Here I'm going to change it to b. And here instead of I will write j. J. Here I will write j. Here I will write j. Here I will write j. So now it's very easy. Now we know these coordinates. Now we have to find out overlap, width, and height. So these two things we need to find, right? So what I'm going to do here, let's say int overlap width is going to be math dot min of, let's see the formula. So a trx comma b trx. So I'm going to write this formula, a underscore trx comma b underscore trx, and here minus of a blx and b blx. So here I will write math dot max of a comma b blx, and here b underscore blx. Clear? Same way overlap height I have to write. So I'm just going to copy this, I'm going to paste it here, and here I write overlap height, height, height. And here atr instead of x, this time y, atry, and here btry, and here math dot max of a b l y, and here b dot b l y. So same thing I'm writing here, this thing. Now I calculate the overlap width and overlap height. Now here I have to make sure that my overlap width, it should be greater than 0, and my overlap height, it should be greater than 0 for the boxes to be intersecting. So now if they are intersecting, then I have to calculate the side, which is going to be the math dot min of the overlap height and the overlap width. So minimum value I need to choose. Once I get the side, now I have to calculate the area. So here in the long we have to return. So here I will write long area is equal to, I will just convert the answer to long only, and here I will just do side into side. So now will get answer in long, and the max area, I told you, it is going to be what? It is going to be math dot max of max area and area. So among them, the max I will choose, and here in the end I'm going to return this max area. That's it. So only 31 lines of code. Now let's run it. So see here, there is some issue. So math dot min of overlap width, it should be like this, overlap width and overlap height. Let's run it again. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And the time complexity for this problem is going to be of n square. So let's see the time complexity from here of n square. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.